Good afternoon, and we are going to examine how to graph a quadrilateral and algebraically find all the values that we need to in order to classify this quadrilateral. Now, first off, what I'm going to do is I'm going to give you 4 points. This is the quadrilateral PLAY, play, where P is at point 3, 2, L is at 11, 7, A is at 16, 15, and Y is at 8, 10. Now, noticing that we are all in the first quarter, or the first quadrant, since every value is positive, I've decided just to draw the first quadrant. And first thing you want to do is you want to plot every single point. 3, 2, here's point P. 11, 7, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. There's PL. A is at 16, 15. So that was 11, 12, 13, 14, 15. 16, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We'll put 16 up there since I'm a little bit off. And we should be at 8, 10. There's 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's the next point. And there's PLAY. Next, what we want to do is we want to connect these points in order to get a good picture of what we're dealing with here. We are never going to draw a 100% accurate graph by hand. But we can do the best that we can. Now, identify the sides. PL is a side. So length PL is a side. LA is a side. AY is a side. And PY is a side. Now, in order to classify the shape, we have to calculate the lengths of each one. So for PL, one way to do this is to use the distance formula, which would be the difference of the x's minus plus the difference of the y's with each quantity squared. So I'm going to take P and L. I'm going to take 8 minus 3, 8 minus 3, and 7 minus 2. I'll get 8 squared plus 5 squared. This is the square root of 64 plus 5, 25, which would be the square root of 89. Now I would take LA and I would say, alright, well, LA, I'm going to use these points here. 16 minus 11 squared plus 15 minus 7 squared, which would be the square root of 5 squared plus 8 squared, which is the square root of 89, as I figured out from right here. So I know PL and LA are the same value. That's an errant mark, but hopefully we find out that that works. AY I'm going to take 16 minus 8 to keep things positive, and 15 minus 10. That's 8 squared plus 5 squared, which is what we've gotten every single time, 89. And so I know that AY is the same value And I know the picture's a little bit messed up, and that's because I had to go off the grid a little bit here. And that happens. We'd have to redraw it if we needed to redraw this in a special case. And then PY, that's the last one. We will subtract the x's. I have 8 minus 3, 8 minus 3, and then 10 minus 2. This is equal to the square root of 5 squared plus 8 squared, which is the square root of 89. Sorry about that. But first off, when we have our shape, we're able to actually calculate the lengths of all four sides. And like I said, I know it doesn't look exactly the same, and that's probably because point A is off the grid. But your distance formula, remember the distance formula, it's your friend. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And that'll get you a length of any side that you need.